So, hi, I'm Tanzi. I would like to solve this question now. So, to determine the displacement of the wave at any instant. So, this is the solution for wave equations, and from this wave equation, what we want to find is the an and bn and substitute into this. Okay, so from this question, this is released, the water wave is released from the horizontal position. So this means that the an is equal to 0. So after this, the an equal to 0, the solution for the equations, it will become this. Okay, yeah, because the an is equal to 0. So the next thing we need to find is the bn. So bn is equal to 2 over n by c and L0. So the gx is here. Okay, so from 0 to L, okay, let me change the L. It becomes gx sine n by x over L dx. And then next thing we continue to do, and then we know that from this, okay, from this part, the gl actually, the range can be separated. So how to separate it? It will become 0, 1 to 1 over 3 else, and then the x sine n by x over L dx plus 1 over 3L to L. So this, from this is 0, and yeah, continue to write. And then anything integrate 0 is 0. So we continues to write like this. Okay, the next thing we need to do is the tabular methods. So differentiate, integrate, and then x 1 and zeros, and this is the sine n by x over L, and we integrate it, it will become this. Integrate it again, and it will become this. So positive, negative, positive, and the arrow. Okay, so we have successful to integrate this. Okay, later we write down the integrations, and then this negative and negative, it will become positive, and yeah, like that. So very simple. And next thing we need to do is we need to substitute the value into it. So after we substitute the 1 over 3 L into it, it will become 1L squared over 3n pi cos, and we substitute into x, and this will become n pi over 3 plus L squared n squared pi squared sine n pi over 3. So until this step, we have successful to find the bn's. Okay, we have completed the bn's. So for the final solution, what we need to do is we need to substitute the bn's into the this. Okay, you can see this formula. So uxt equal to, so now here, okay, we have some place. Okay, then we continue to substitute the bn into it. Cos n by 3 n squared by square sine n pi over 3, and then don't forget that for the formulas you have these two sign here. So continue to write down, and this is our final solution for this question. Now I would like to continue to solve this question. So from this question given, it has two equations we need to find. So I will separate it into two parts. So let us find this first. So I will use the D'Alembert method to solve it. So from this methods, we need to find ff and gx. Fx will refer to the v, the velocity, e power of x, and the gx will refer to the partial differentiations. And now we need, from this equation we can find that there are three things we need to find. So how to find these three things? So I would like going to show you. So fx minus ct is equal to this. Yeah, this come from this part, and then the next thing is EX plus CT. So this also comes from this part. After we get this, we continue to substitute it back into the solutions. So E minus CT plus EX plus CT. Okay, and then this plus 1 over 2C. So this is a integration here. Okay, we continues to this we can substitute it out, becomes ECT plus ECT. E minus CT. Okay, and then this bracket I changed a little bit. Okay, after this, and we integrate this, it will become tangents, the inverse tangents S plus CT S minus CT. Okay, so for this part, we know that this can be simplified into the what we call the hyperbolic functions cos CT. Okay, and then this we continue to substitute the values into the from the tangents, and we will get this. So this is at all for the part 1. So we have successfully to find the equation of the part 1. Continue to solve the equation for the second part. So the second part is a P. Okay, so from this we know that Ps is 1, so the Fs is 1, and the Gx is refer to the partial differentiations. And then now we continue to use the same way to solve it. So no matter this is negative CT or plus minus CT or plus CT, it will become 1. So we can directly substitute it, become 1 plus 1 plus 1 over 2C. And same thing we need to using the integration here. So this will become 1 plus 2C. After we integrate the hyperbolic secant x, we will become hyperbolic tangent x. So we need to substitute the value into it. Minus tangents, yeah. So this is the final solution for the second equation, and the question is n. Thank you.